Today we're going to talk about digital input. So, just to review, let's remind ourselves what digital means in the context of programming Pico. So, digital refers to the idea that there are only two values. There is 0, and we can think of it a lot of different ways. We can think of it as 0 and 1, or we can think of it as false and true. We can think of it as off and on, and we can think of it as low and high, or what these really refer to is the voltage. So low voltage on the Pico is 0 volts, and high is 3.3 volts. So that's what digital means. And of course, input, well, we've already talked about output. This means that the Pico has put a high or a low voltage onto one of its pins. So external devices can be controlled in that way. Today we're going to talk about the input part, which is that the Pico actually reads high or low voltage on one of its pins. Okay, so why would you want to do that? That's a great question. There's several different, there's quite a few different applications, really. For example, you might have a sensor, like let's say you have a garage door, and if there's something in the way, it will trigger a signal that's either high or low. So either triggered or not triggered, and maybe a microcontroller takes some action. Maybe you have a system where there's that's triggered on a sound reaching a threshold. Maybe temperature reaching a threshold, and it turns on a fan or something like that. So there's a million different uses. Oftentimes what we do is we want to control something through the Pico. So we use a button, and the button actually allows us to give a digital input into the Pico. And when the Pico receives that a 0 or 1 or high or low value, it can respond appropriately. All right, so let's go ahead and start taking a look at a circuit that we might use. So if you are building a circuit with a button, then what you really want to do is you want that button to either put in 0 or 3.3 volts into the Pico. Now you might remember that the Pico actually has a pin right here that's labeled 3V3 out, and this is shorthand for 3.3 volts out. That's always available, so we can actually use this as the source of our 3.3 volts. So if I draw this, I'm just going to draw a pin with a circle, and I'm going to do 3.3 volts to represent that particular pin. Then we draw a lead and then our button. So if you'll recall, the symbol for a button looks like this. It's almost like a little picture of what a button might do. If you push down on it, it'll actually make a connection. And then finally, this goes into the input pin. So we're going to pick a pin, and I'm just going to pick pin 2. All right, so very simple circuit. If I press this button, 3.3 volts should show up here. All right, I'm going to go ahead and build that. Now, I like to have a, if I'm going from the positive, which is, so it's 3V3 out. It's here, which is 5 on the right-hand side, so I'm going to go to 5 over here. I like to use red when it's coming from 3.3 volts, the positive. All right, so I'm going to go, I guess I'll put it, you can put it anywhere you want. I'll put it down here. And now I'm going to go ahead and get my button. There's a lot of different types of buttons. If you're experimenting with this, you want to make sure you get one that fits nicely into the breadboard. There's 2 pin versions and 4 pin versions. This is a 2 pin. I'll put it in here. And notice that one of its legs goes in the same row with this. And now all I need to do is go from the other leg of the button all the way back to pin 2. Okay, so because the other thing is more of sort of a signal, I'm gonna just give it a color other than red or black. Black usually means ground. So I'm just gonna use this. It's gonna go here. And then pin 2. Remember, pin 2 does not mean the second row on the breadboard. If I find it, where would pin 2 be? Can you just point to that for me? Oh, okay. A little hard to see where you're pointing because you have more of like a paw, but yeah, so pin 2, and this is GP2, and that is 4 on the left-hand side. Okay, cool. So go ahead and do this, and I'm going to go over here, and so there are my connections. So there's my simple circuit, and let's go and switch to our Thonny. All right, so I usually, just as a general habit, I go ahead and reselect, make sure it's connected to the Thonny, but I know it is because I can see the files over here. This is the Raspberry Pi Pico files. All right, so let's go ahead and start. I'm going to do, I'll just call it, well, let me get started this way. First of all, I'm going to need to do my imports. So from machine import pin again, I will probably need my sleep. So I'm going to go ahead and import that from time import sleep. All right, so we've configured our pins. Sorry, we've brought in our libraries. Now let's configure our pin. So I'm going to name the pin that is receiving the input from the button. I'm just going to call it button, and it's going to be equal to pin. And the number of the button, what was it again? I think it was 2. And instead of pin.out, it is pin.in. All right, as you might expect. Now, there is one other thing I need to do here, and I'll explain this in a bit. But for now, I'm just going to do pin.pull down. All right. Now, so I'm going to use a while loop, and I'm just going to measure the value at this pin 2 over and over and over again and see what happens. And I'll print it out. So while true, and I'm just going to, let's see, I'll actually, I'll assign the value that's at the button to a variable. So value is equal to button dot value. Okay, so first of all, this value method, so it's got parentheses, so it means this is a method that belongs to this pin object, and it will give me either 0 or 1 depending on whether the button is pressed. Now I've decided to actually take this and assign it to a variable, so I'm just storing it in this other variable temporarily. All right, now I am just going to go ahead and print value. So you might notice I could probably just do print out button.value directly, but I chose to do it this way. And now I'm just going to put in a little sleep, 0.1, so 1/10 of a second. All right. Now, let's go ahead and save this. It's asking me where. I will call it button.py like this. All right. Now, I am going to go ahead and run this code. So if I run it, then you'll notice a whole bunch of zeros are showing up here on the screen. If I push the button, then you'll see that ones show up. So it definitely is working as intended. Awesome. Now there is another thing, a feature of Thonny that is really, really useful. If you have numbers that you're monitoring, whether they're digital or maybe, when we get into an analog as well, you can actually go to your view menu here, and you'll notice that a little bit further down it has a little thing called a plotter. And the plotter will actually take whatever you're printing out and attempt to plot it on a simple little plot. I see this being hidden by my webcam, so let me just move that out of the way. Okay, I press it, and there it is. So you can see that it's actually a nice way to visually see what's going on. Okay, I'm going to take this opportunity to go back and explain something that I mentioned before, and that is this command, pin.pullDown. So what this means is that when the button is not pressed, then the value at the pin should be read as low or 0. What happens if you look at what's going on actually with this the diagram of our circuit here? If the button is pressed, then the pin is directly connected to 3.3 volts, so there's no ambiguity there. However, if the button is not pressed, it's just like there's a little strip of wire that's being fed in here, and nothing is pulling it either high or low. So what happens is this kind of acts as an antenna. So the idea is if it's not explicitly being pulled, you know, if it's not explicitly set to high, then to set it to 0. So let me show you what happens if I were to get rid of this code right here. I'm just going to delete it, and we're going to run this again, and you'll see what I mean. Okay, when that happens, that means you need to stop the program, because remember, we're in a while loop, and while true loop. And if I run it again, then notice how it is just sort of spontaneously gone high. And that's the problem with it, is it's just unpredictable. So it might be high, it might be low. It just really depends on what's going on in the atmosphere. A lot of times it's just acting like an antenna for a radio. So right now it's high, but it could actually go to other values as well. All right, so I'm going to go ahead and put that back in, because otherwise it just gives really unpredictable. Oh, see, it's gone down by itself. Pull down. All right, so I'm going to stop this again and save this. Okay. Now, now that we've gotten a button, sure, we can make it go high and low. We can plot it out if it's connected to a computer, but what's the purpose of this? Well, usually when you have a button that's being read by a Pico, it means that we want the Pico to do something when it receives that button press signal. So I'm just going to go and revisit the what we did before, which is the LED circuit. So you might remember that previously we had a little circuit to light up an LED under the command of the Pico. So I believe it looks something like this. Pin 9 is what we were using, and then an LED, and then ground like this. So there's my LED, and this was 330 ohms. So here's the idea. I'm going to have two separate circuits, and I'm going to use this circuit to tell when the button is pressed, and based on this, I'll change what the LED does. All right, so I'm going to go ahead and finish this circuit, and let's see here. So I have pin 9. I will go and, let's see, where's pin 9? Pin 9 is 12 on the left-hand side. 12. I'm going to go down here. I'm going to get my resistor, and then my LED. If you ever need to check to make sure that your LED is working, a little trick is to use this. Looks good. Use your little coin cell. It's not going to burn the LED out. I'm going to do this. And then finally, I'd like a nice black wire to go back to ground. And any ground will do. Let's see here. Looking at my map here again, I can do this right here. So 18. All right. So now I have two different circuits. They're not actually connected to each other directly, but they're both connected to the Pico. So what I'm going to do is I'm going to go back to my code here. And what I'm going to do is I'm going to have the LED change its state from on to off, or if it's on to on, if it's off to on, when the button is pressed. So I'm going to use a method that's called toggle. So the toggle method on a pin, when it's an output pin, a pin that outputs a digital signal, will change it from 0 to 1 or back 1 to 0, depending on which one it is. It'll be set to the opposite of its current state, is probably the best way to put it. All right, so in order to do that, I'm going to use another very important programming principle, which is a conditional or an if statement. So what I'm going to do is, right in here, this is the way that you do an if statement. You literally start with the word if in Python, and you do if value is equal to 1. Notice the two equals. We don't use double equals to compare two things. And in programming languages, typically don't. And the only one I know about it is Scratch that does that. Almost every other language uses two equals to see if these two are equal. So this is a test. This guy right here is a test, and it has a special name, and it's called a Boolean expression named after George Boole. So if value equals 1, and we're going to go ahead and return, and notice how it's indented. So the idea is, if this is true, then all the statements directly below the if statement and indented will be executed. All right, so all I'm only going to do is I'm going to do led.toggle. All right, you know what? I forgot to actually define my LED pin. I'm going to go up to here. I like to group these together. LED equals pin, and we decided it was pin 9. And I'm looking on my sheet here, and pin 9 is 12. I already did that, so I can just use the GP value pin. And remember, this one is an output. Okay, so toggle, and then I'm actually going to put in a little bit of a sleep here, and I'll explain that in a second. 0.2. All right, so let's see how this works. Actually, I think I will, before I start the program, I'll shut this off. All right, let's go ahead and see how this works. So whenever I press this, the light should either go on if it's off or off if it's on. So I'm running my code, and there it goes. So I press it, it goes on, press it, it goes off, press it, it goes on. All right, so this is just one example of the million different ways you can use a button press to do something. Anything that you want to control that's sort of on or off, you can use this strategy. Now, one thing that's interesting, notice what happens if I just hold it down. You'll notice that it just blinks on and off, and now you might think, why does it do that? Well, if we go back to the code, this is where this sleep comes into play. Remember that this is executing over and over and over again, so it keeps testing to see if the value is 1. If it is, it will toggle, and then it waits 0.2 seconds. So if I hold it down, it'll just repeat this little piece, but it'll sleep 0.2 between the changes of the button, of the LED state. So in general, like if I didn't have this here at all, it would just almost be random, because it would read the value, toggle it, but it would look at the value again so quickly it wouldn't really have a chance to stabilize. So a lot of times when you're using a button, you may need to put in a little bit of a sleep.